So if you show an AI a video of a man standing perfectly still, right?
Yeah.
And you hand it a piece of paper that says he's doing a backflip,
Right.
the smartest machines on Earth will literally look you dead in the eye and tell you he's an acrobat. Like, they don't just lie, they hallucinate entire, physics engines to justify the lie.
Yeah, it's wild. It's a massive problem.
It really is. And today, we're looking at the team of scientists who are actually trying to fix it. So welcome to the deep dive. Whether you are, prepping for a tech strategy meeting, or you're just wildly curious about how artificial intelligence actually constructs its version of reality, our mission today is to unpack a state-of-the-art generative AI research paper. It's titled ModeRag.
ModeRag, yes.
Yeah, and we're diving into how researchers are finally stopping AI from confidently lying to us, especially when it mixes video and text.
To really grasp what this paper achieves, we first need to look at the tech it's actually trying to save, right? Which is MRG, multimodal retrieval-augmented generation.
Right. So let's ground that for you listening. Standard RAG is, it's when AI goes out and searches a database to help answer your question, instead of just relying on its internal memory.
Exactly.
So multimodal RAG just means it's doing that with different types of media. So if you upload a video of, say, a weird bird in your backyard to an AI, the video of the bird goes out to retrieve a Wikipedia article about local wildlife and uses both the video and the text to tell you what kind of bird it is.
Right. It's supposed to be this ultimate synthesis, giving the AI eyes to see the real world and an encyclopedic brain to reference the facts. But
there's a catch.
A huge catch. This is the catastrophic flaw that the paper addresses. MRAG systems suffer from wild, cascading hallucinations the moment the video they're looking at and the text they retrieve contradict each other.
And from the sources we're looking at today, this isn't just the AI accidentally, confusing a shadow for a feather. The paper describes two distinct, I guess you could call them psychological flaws in the machine's architecture.
Psychological flaws is actually a really great way to think about it, because mechanistically, the first flaw is what they call sycophancy.
Sycophancy, so it's a flatterer.
Exactly. These AI models are fundamentally trained via human feedback to be helpful, to please the user. So they have this deep-seated bias toward agreement. If a user's text prompt, or even the retrieved Wikipedia article, aggressively pushes a specific narrative, the AI will blindly agree with the text.
Wow.
It effectively overwrites its own visual evidence.
So it's a total people pleaser. If the text says, look at this majestic eagle, the AI looks at your video of a pigeon and just says, oh yeah, what a beautiful eagle.
Precisely. It prioritizes the semantic suggestion over the actual visual reality. And that leads directly to the second flaw, which the researchers call causal imposition.
Causal imposition. Okay, break that down for me.
Well, because the AI wants to please you, right, but it still has to somehow account for the video of the pigeon. So it starts inventing physics or logical sequences that simply are not happening in the video just to bridge the gap.
Wait, so it just invents a story?
Yeah, it creates a fake causal chain of events. It might say that the pigeon is actually an eagle in disguise, or, that the eagle just flew out of frame. It imposes a reality that doesn't exist just to make the conflicting data fit together nicely.
That's terrifying, right?
Yeah.
Which brings us to this massive roadblock the researchers call the intervention paradox. And I was reading this part and just trying to figure out, how do you even begin to fix a system that fundamentally wants to lie to you?
It's incredibly difficult.
Right. So the paradox is basically this. If you give the AI incredibly strict, hard-coded rules for every single question, like you tell it you must independently verify every noun and verb 3 times, it overcorrects. It gets bogged down.
Yeah, it becomes paralyzed.
Exactly. It starts getting the simplest, most obvious questions completely wrong because it's constantly second-guessing itself.
Right, because static rules disrupt the natural fluidity of accurate generation. That's the first half of the paradox.
But then the second half is, if you remove those guardrails and let the AI freely associate, the slightest contradiction cascades into a fictional essay. You get the eagle-pigeon hybrid.
Yep. And the solution this paper proposes, ModeRag, it actually abandons the idea of a single AI brain entirely. Instead, it builds this highly decoupled multi-agent system.
So it's team.
Exactly. It's essentially a specialized committee of algorithmic fact-checkers and decentralizing the processing, moving from a monolithic brain to a structured chain of custody for truth. That is how they bypass the paradox.
Okay, but wait, I have a massive structural pushback here.
Go for it.
If the whole point is that we're dealing with this intervention paradox and we don't want the system getting bogged down on the simple questions,
Right.
how does the AI even know when to call in the committee? Because if you put a gatekeeper in front of the system to detect hallucinations, what stops the gatekeeper itself from hallucinating? Aren't we just, I don't know, moving the problem one step to the left?
That is the exact vulnerability you'd expect. And it's why their solution for the gatekeeper doesn't rely on language at all. It relies on something called variational free energy, or VFE.
VFE. Oh.
Yeah. The researchers built an adaptive router at the very front of the system called the FE router. It doesn't ask, is this text true? It probes the model's internal ATLS attention states to calculate epistemic uncertainty.
Okay, wait. Variational free energy and ATLS attention states. We need to translate that.
Sure.
How does an algorithm experience uncertainty without using language?
It all comes down to predictive coding. So in neuroscience and thermodynamics, free energy basically measures the discrepancy between what a system predicts will happen and the actual sensory evidence it receives.
Oh, interesting.
Right. So deep inside the neural network's attention layers, those are the ATLS states, the AI is constantly predicting the next logical connection. When it sees the video of the pigeon, its internal math predicts pigeon-related concepts. But when the incoming text feed aggressively injects the word eagle, those two mathematical realities clash.
So it's not reasoning about it like a person would. It's a literal physical clash in the code.
Exactly.
I'm trying to picture this. It's almost like the AI is starting to sweat.
Sweating, I like that.
Yeah, like the internal energy of the system spikes because the predictive engine is grinding its gears. It expects one reality, gets fed another completely different one, and experiences this high epistemic uncertainty,
Right.
like internal stress.
That is a highly accurate way to visualize it, honestly. The FE router is basically just a thermometer measuring that sweat. If the variational free energy spikes above a certain threshold, the router triggers the alarm.
It calls in the committee.
Exactly. It says, we have a severe reality mismatch, and it diverts the query into the heavy multi-agent pipeline. But if the energy is low, if the video and text perfectly align and the system is confident, the router bypasses the complex pipeline entirely, avoids the overcorrection.
That answers the paradox perfectly. I mean, you don't send the SWAT team for a parking ticket, right?
Right, exactly.
You only send them when the internal energy spikes. So, okay, thermometer breaks, the AI is sweating, we've diverted the query. How do you even begin to de-escalate that internal panic?
Well, you isolate the senses. The moment the query is averted, it enters this 5-stage ecosystem. And the most critical rule of this ecosystem is total isolation. Agent 1 is the per agent, or perception agent.
Okay.
Its only job is an atomic facts objective scan. During this stage, the system physically cuts off all access to the retrieved text. The per agent only stares at the visual stream to extract symbolic triplets.
Why cut off the text completely, though?
Because of the sycophancy we talked about earlier.
Oh, right.
If Agent 1 can see the text will bribe the AI's eyes, essentially. By isolating the perception, the agent is forced to pull out hard, undeniable data points.
Like literal subject-verb-object triplets, like bracket, man, is stationary bracket.
Exactly. It creates an unbreakable, grounded truth anchor. It establishes the physical reality of the scene first. And once that anchor is set, Agent 2 steps in. This is the core agent, or correction agent.
Okay, and the paper describes the core agent wrapping these visual facts into a strict programmatic schema, like a JSON format. Let's unpack the mechanism there. Why does the format even matter?
Because natural language is fluid, right? It's ambiguous. If Agent 1 just writes a sentence saying, the man is standing still, a later agent might interpret that as, he's standing still before he does a backflip.
Oh, I see. It leaves room for interpretation.
Right. So the core agent acts kind of like an ice cube tray. It takes this fluid, messy, ambiguous water of natural language and freezes it into rigid, usable blocks of code, the JSON schema.
Wow, okay. It locks it into strict key-value pairs so it absolutely can't be misinterpreted later. I think the paper calls this blocking semantic noise leakage.
Yes.
You're basically forcing reality into a format where the words just can't be twisted.
Exactly. And now that we have frozen, clean data, we introduce Agent 3. This is the RET agent for retrieval. And this is where we finally let the external text back into the room.
But carefully, I assume.
Very carefully. The RET agent acts as a bouncer. It calculates the manifold distance in the latent space between the retrieved text and our frozen visual triplets.
Okay. Manifold distance in the latent space. We're back in the jargon.
Fair enough.
How does distance actually root out a lie?
Think of a latent space as a massive, multi-dimensional map of every concept the AI understands.
Okay.
On this map, concepts that mean similar things are physically closer together. So the concept of stationary might be in New York, the concept of sitting might be in New Jersey, but the concept of a backflip is all the way over in Tokyo.
Right, so the red agent takes the frozen visual triplet, which is sitting in New York, and maps the coordinates of the retrieved text. If the text says backflip, the algorithm calculates the physical distance between New York and Tokyo, realizes it's an impossibly huge gap, and flags it.
Yes, exactly. When the spatial distance between the two realities is too far, it triggers a conflict discard. The red agent literally throws the hallucinated text in the trash.
It just deletes it.
It deletes it from the context window entirely, so it can't infect any of the downstream reasoning layers.
Wow. It just unplugs the mic on the text. So what happens with the clean text that actually manages to survive the bouncer?
That gets handed to Agent 4, the Rhea agent, and this is the cognitive engine of the entire system. It uses Monte Carlo tree search, or MCTS, to build a causal-directed acyclic graph, a DAG.
Monte Carlo tree search. Wait, isn't that the exact same mathematical process that systems like Deep Blue or AlphaGo use to beat human grandmasters at chess?
It is, yeah.
How does chess logic apply to figuring out what's happening in a video?
It applies beautifully, actually. The Rhea agent looks at the frozen visual facts as the starting position on the chessboard. Then it draws logical arrows, that's the directed acyclic graph, to simulate different consequences step by step.
Oh, I see.
It asks, if piece A is here, can piece B logically move there? Or in our case, if the subject's current state is stationary, is the claimed action of a backflip physically reachable in the very next frame?
That's brilliant. It's literally playing logical chess with reality.
Exactly. It rolls out all the possibilities, evaluates the physical constraints of the scene, and then prunes away any branches of reasoning that violate causality. It builds this rigorous, mathematically verifiable map of what is logically possible based on the video.
And then we reach the finish line, Agent 5, the Gen agent. It takes that logical chess map and synthesizes the final answer for the user. But looking at the paper, it's not just generating text normally, is it?
No, it's not.
It uses something called logic perturbation. Let's break that down. How do you perturb a logic to stop a hallucination?
Well, to understand logic perturbation, you have to know how an AI selects words in the first place. It doesn't think of a sentence. It calculates a massive list of probability scores for what the very next word should be. Those raw scores are called logits. Imagine a giant roulette wheel where every single slot is a word in the dictionary, and the size of the slot is based on its probability score.
Okay, so if the AI is talking about the sky, the slot for the word blue is massive, and the slot for green is tiny.
Right. What the Gen agent does during logic perturbation is cross-reference that roulette wheel with the causal chess map from Agent 4. If it sees that a hallucination keyword, let's say the word backflip, has a high probability score on the wheel, it actively intervenes.
It changes the wheel.
Yes. It mathematically shrinks the backflip slot to near zero.
So the ball literally cannot land on the lie.
Yeah.
It artificially punishes the hallucination words at the mathematical level, so the AI physically cannot synthesize them.
Exactly. While simultaneously boosting the tokens that align with the objective facts, it acts as an absolute information bottleneck.
Man, I have to pause here because there's a detail in the experiments regarding this generation phase that completely blew my mind.
Oh, the dead man switch.
Yes, the dead man switch. The researchers found that sometimes when a standard AI gets completely overwhelmed by contradictory text and video, it suffers from what they call mechanistic mode collapse. It basically has a panic attack.
It's a fascinating and honestly kind of disturbing phenomenon.
Yeah.
In standard models, when the predictive coding is torn between satisfying the visual evidence and satisfying a highly aggressive text prompt, it gets caught in an infinite loop of uncertainty.
The paper noted it will literally just start stuttering.
Yeah.
Outputting its endlessly, or it will just break character entirely and start leaking its own internal metadata onto the screen.
Yeah, because the architecture is basically tearing itself apart, trying to reconcile the irreconcilable.
Right.
But the Gen agent in ModeRag has a built-in dead man switch. It monitors the generation for these arithmetic panic attacks, and if it detects a catastrophic formatting failure, it triggers a deterministic interceptor.
So what does that do?
It safely downgrades the system out of multimodal reasoning entirely. It drops it into a basic reading comprehension state. It establishes a hard safety floor so the system never spirals out of control.
It catches the machine before it faints.
Yeah.
That is wild. Okay, so we've gone deep into the mechanics of these 5 agents. Let's look at how this plays out in the real world for you, the listener, because the paper has this brilliant adversarial test in the appendix. Scenario 3.
Ah, yes. The snowboarder.
Let's talk about the snowboarder.
This scenario is the perfect demonstration of the entire architecture. So the visual ground truth is incredibly mundane. It's just a short video of a person standing completely still on a snowboard in a forest. That's it.
Nothing happening.
Nothing at all. But the researchers purposefully feed the AI retrieve text documents that are filled with high adrenaline keywords about competitive winter sports, Olympic trials, and surviving massive avalanches.
They are actively trying to trigger that sycophancy we talked about. So what does the standard baseline MRAG model do with this?
It completely loses its mind. The baseline model hallucinates an action movie. It tells the user that the person in the video is performing a triple cork 1440 spin while outrunning an avalanche.
Unbelievable.
The visual evidence of a stationary person is just entirely hijacked by the excitement of the text.
So how does ModeRag, with its 5 agents, fix this Hollywood director complex?
It brings in the final supervisory piece of the puzzle. The overseer agent running the PORAG protocol, that's policy-oriented RAG. Before that drafted text about the triple cork is ever shown to the user, the overseer performs a triple consistency check.
So it's auditing the committee's work.
Yes. It compares the frozen visual triplets from Agent 1, the causal chess map from Agent 4, and the final drafted text. And the overseer realizes, wait a minute, an avalanche and a triple cork cannot be logically derived from a stationary snowboarder.
Right. The physical realities just do not match.
The fidelity score crashes. And this triggers a recursive fallback loop. The system essentially says, we have an unresolved conflict, and it sends the query back to the reasoning agent to search deeper, giving it a bigger simulation budget to try and actually find the avalanche.
It basically tells the AI to stop and think harder.
Yes. But here is the genuine breakthrough. If, after multiple recursive attempts, the system still cannot reconcile the text with the video because one of them is clearly a lie, it performs an epistemic refusal.
Epistemic refusal. Okay, what does it say?
The final output to the user is, the man stands stationary on the snowboard, insufficient information to determine the background of this event.
Oh, wow. That is massive. Teaching an AI how to safely say, I don't know, or the data doesn't make sense, rather than confidently hallucinating a lie. I mean, if you think about the stakes of this, imagine an AI reviewing your MRI scan, comparing it to your medical history text. You do not want that machine guessing.
Definitely not.
You want a system that has the mechanistic self-awareness to say, the image is blurry, I don't know.
Exactly. The ability to express calibrated, mathematically verified uncertainty is the absolute hallmark of a reliable enterprise system.
So let's look at the hard data. Does this highly decoupled committee actually work at scale? Or did they just build a really good snowboarder detection algorithm?
It definitely works at scale. To prove it, the researchers created a custom benchmark dataset called ModeEvent. It contains 1,000 highly curated video text samples. 500 of them are low-risk inlayers, where the text and video mostly match. But the other 500 are high-risk outliers, adversarial scenarios deliberately designed to break the AI's grasp on reality.
And we need to point out a very specific detail about the data they used for these outliers. They deliberately fed the AI highly charged, messy, real-world data. Specifically, some intense South Korean political controversies involving internal party disputes, leaked audio, and press conferences. And just to be absolutely clear to you listening, the researchers weren't doing this to make a political point, and neither are we. We are completely neutral here. They used this political data because human politics is the ultimate stress test for an AI. It is full of slang, contradictions, bias, and information sparsity.
That is exactly why it was included. If you want to test how an AI handles out-of-domain irrelevance and aggressive textual bias, political debates are the most adversarial environment you can possibly put it in.
Right. It's the ultimate test of sycophancy. So, running this 1,000 sample gauntlet, how did ModeRag actually perform?
It dominated. The standard baseline model had an overall fidelity score of 4.40. ModeRag jumped all the way to 5.45.
Wow.
It also significantly beat out other state-of-the-art mitigation models currently on the market like SelfRag and Woodpecker. But where ModeRag truly separated itself was in those outlier scenarios with a massive text bias. When the text was aggressively trying to hijack the narrative, ModeRag successfully ignored the noise and anchored itself to the physical reality of the video every single time.
That is a staggering jump in accuracy. But I have to ask the practical question here. We are running an FE router, 5 different isolated agents, Monte Carlo tree searches, recursive fallback loops, and logic manipulation.
That's a lot of computing.
Exactly. What is the catch? This amount of processing cannot be free.
You're right to look for the trade-off. And the catch is computational cost, specifically time. On their testing hardware, a standard vanilla AI query took 18.5 seconds to process. ModeRag, running its full multi-agent orchestration, took an average of 26.2 seconds.
Okay, so a jump from 18 to 26 seconds, that's about a 1.4x increase in processing time.
Yeah, it adds roughly 7 to 8 seconds of delay to every high-risk query.
Which poses a really interesting question for you, the listener. If you are deploying an AI for your business, maybe analyzing legal contracts against visual evidence or relying on it for medical research,
Right.
is an 8-second delay worth an ironclad guarantee against hallucinations? I think for most critical real-world applications, the answer is an overwhelming yes.
I agree completely. In a high-stakes environment, the cost of acting on a hallucinated fact far outweighs a few seconds of compute time.
So, to synthesize this entire journey we've been on today, the architecture of artificial intelligence is fundamentally evolving. We are moving away from the era of a single, monolithic, people-pleasing brain that is prone to hallucinating wild stories the moment it gets confused.
Right.
Instead, we are entering the era of thermodynamic AI. We are building decentralized, multi-agent bureaucracies, teams of algorithmic fact-checkers, logic trees, and dead-man switches, all constantly monitoring internal energy, isolating their senses, and mathematically checking each other's work just to arrive at the objective truth.
It is a profound architectural shift. We are moving from systems designed purely for generation to systems designed for rigorous verification.
It really is a paradigm shift. But before we go, I want to leave you with a final thought to mull over. ModeRag is a brilliant breakthrough because it uses objective, physical, visual facts, like a snowboarder standing perfectly still or a man on a sidewalk to ground its reality.
Yes.
It can literally map out the physics. But as we increasingly rely on these highly decoupled multi-agent committees to govern AI truth, what happens when we ask this system to analyze a situation where the ground truth isn't based on physical physics? What happens when it's analyzing a nuanced human interaction? Or a subjective moral conflict in a video? If it takes a 5-agent committee, an energy router, and a Monte Carlo tree search just to confidently agree that a snowboarder isn't doing a backflip,
Yeah.
how is this technology going to handle the messy, unquantifiable reality of human behavior?
That is the frontier, and it raises an incredibly important question for the next generation of multimodal research.
It certainly does. Thank you so much for joining us on this deep dive into the architecture of truth. Keep questioning the systems around you and stay curious.